import or install or something, install any packages, everything is available in Collab. It's available. Chat GPT something. So it's downloading this BERT and all tokenizer. Everything is being downloaded, and now we are getting it. Right? So uh,
So what is the input data in this that we are tokenizing?
this is the input data.
Only this one sentence.
Yes, one second.
Okay, sir.
So let's say sentence embedding. I do. So this is how the sentence is looking here. Right? So it's now huge. You can have shape of it. Mm, it's a 768. You can say points in it, right? So 768 column. Uh, so it's a one column and 768 rows in that. You can consider it. It's a vector. 768 points are there in this vector for the embedding of this. So currently we are doing sentence embedding, and you can do word embedding also. So word by word you can embed, like this will look a different, product will look different, is will look different, amazing will look different, and that's also you can do. So but I think as of now we are doing uh, the text as a feature. So this one sentence will now look like this 1768 size of column vector. Okay. So this is what you'll get as a shape and all. You can have a token of bigger size and all, and that you can use to train the whole model. Like so after this embeddings, you can definitely use anything, right? Like let's say dictionary classifier, or you can use naive base anything, because it's a text data. Most likely you'll have that. I don't have labels for this. What is it about sentiment analysis or whatever it is? So I'll not do, but that's where this collabs comes into the picture. So collab is also available to you, right? So you have this part in development. So practical implementation, if you go, this collab is there. The same thing. Uh, Now here we are using TensorFlow. Earlier we used PyTorch to show the thing. So this is an example notebook given in the course itself. That's why I'm using it, and 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 some data set I'll use for it. So it's currently IMDb data set, and you have to predict what is the I guess sentiment of the thing, right? Give me- so this all imported here. I will just get the data. So data is downloading. Uh,
Sir, where can we find this notebook?
It's in the course practical implementation for transfer learning. That this is the notebook link,
Okay, sir.
and the lecture is also about that only. Okay. So so see here, what we are doing is we have the data of movies which we have downloaded, and you can see train labels. So there are 25,000. Okay, and you can see this. Say uh, it's also zeroth class. If I'm aware about this, it is about is it a good movie or a bad movie, right? So based on IMDb uh, data set, you have to define that what is the sentiment about this movie, right? Is it a good movie? Is it a bad movie? What do you say about that? Okay, that it's
Sir, in previous you wrote about text like in a sentence. There is a shape like uh, 2, 3, 4 word sentence. It's like a
this one.
um, shape of what, sir? It convert into this rows, 768 rows. Like
So currently this is indie. So what you can do is you can decide. Let's say you want how you want your embeddings. You want sentence wise, word wise, paragraph wise, even you can have character wise also. So THIS. So depends on how you want it. But here we are doing sentence wise, and the sentence itself have now been transformed to this vector. Right? So whatever this vector sentence embedding is, that vector is representing the whole sentence. Okay.
sir, it looks like we did in count vectorizer type this thing.
Yeah, same thing. Count vectorizer and all, but count vectorizer is statistic. Like you don't know if you are doing the right embedding for a thing, right? So what you are doing there is you are saying that as many time it will repeat. I'll just add one number to it. But embeddings are little different. They represent. Um, so let's say you have one cat, and another is, let's say, dog, and third is truck.
Hmm.
So you want to have a cat and dog to these vectors to be near to each other, because they represent something similar, right? Something they eat, they sleep, they are pets, right? Domestic animals, something. So they should in context.
Means they correlate with each of the feature. All the features are cat is different and dog is different. So through this feature, yeah, these identify.
Yeah, you can say it. So this vectors will project in similar direction, but truck will be far off, right? So see, you are not aware of embeddings and also it will be a little bit difficult, but you can consider that whatever we are doing in count vectors and all, we are getting it to numbers, and same thing we are doing here, but now we are using deep learning to do it. And we use deep learning model, like so one of that is this BERT model, which is a transformer, and transformers are like chat gpt, and all of them are transformers only. And initial, like, BERT model is something you can use, right? BERT tokenizer, which is a embedding uh, mechanism, you can consider like that as of now.
Through neural network.
Yeah, neural networks. So we are getting this numbers. You can say count vector, like similar to count vectorizer, right? So that's what we are doing, and we are getting this classes, right? So these are the labels. This just now I haven't done anything. I just downloaded the data. This is about IMDb reviews. So either is it a good movie or bad movie? That's what it is
So,
classifying. Okay. If uh, if can do unique. on this can do MLP dot. Okay, so 0 and 1, right? Only two classes. So it's a binary classification data. Now what we are going to do is, you can see one of the training example that this whole sentence is is being written about the movie, right? So somebody gave the review on IMDb that movie is whatever, like, and Nicolas Cage was there, gently, whatever, like plot and everything is given about that, and 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 now what we are doing is we are using this NNLM model, but like we use BERT to convert it to numbers. So you can use something which is trained here on news data, right? So you can see various news data they've used to train this model, and still we can use it, right? So let's say you have something like chat bot. You want to build a chat bot, and you want to convert text to numbers. You can use this. Okay, so this is about news, but still it will work. That's how the transfer learning is about. That you don't need to train the whole model, or to train the from the scratch to get the word embeddings, right? So you can use this model. Now we are better also, but something like this will work, right? So this will give you text embedding, and here they have used news data to train it, and that's what we'll use to get the model. So you have to provide the link of that. Now uh, um, um, like something. So how will you find this models? Is you can maybe go to Kaggle. You would have account. You can go to models, and this all DeepSeek R1 you can import. Right. So this link, if you can, not this, but you have to use, or you can download. You can use the code of it. So somewhere it's being written how to utilize this, right? So that's how you can import DeepSeek and Aya, DeepSeek R1, something. So all of them, then you can utilize, which are free to you. You can utilize. Maybe there could be paid models as well. Depends, right? So as of now, we are using this um, NLM, which is on news data, to convert it to numbers, and that we'll use to train the model later on, right? So that is the idea we want to go ahead, and model. I'm importing Uh, so something something. This is just a example given how to do that. Like, mm, so here you can mention that are they trainable, true or false. So if I mention true, that means when I do back propagation, I have to update weights of this thing also, but I don't want that, right? So that's what transfer learning is. So this making it false and using it is what transfer learning in this, right? That I'll use the trained model which is already trained. I'll not retrain it. I'll not spend my resources to do it. So I'll use this some model name which I defined here, given a link of that, and then data type, what is expected, something like that. You can give. So fit 10 transforms you have to give, and then you can see uh, make pipeline text feature extractor, which is this class, right? So earlier, um, so what actually we are doing here is this part class text feature extractor, and then defining initial, fit, and transform. This is a base class given in sklearn itself, right? So this sklearn is providing this base estimator class, and we are you call it as a inheritance, right? So class inheritance is what we are doing it. We are inheriting this models and using it to make it as a model. Now this text feature extractor is itself a model now. So whatever you are doing with sklearn models like logistic linear regression, same thing it will do like this. So you'll create an object of it, right? So this here thing, it's the object being created, which will convert it to text. It will produce something, right? A return self. So this will return uh, itself, right? So or maybe transform. You can even say it will return transformed version of this given input, right? So whatever input you'll give, it will give a transformed version of it. And based upon that, I'll train SGD classifier, right? So you can see I'm fitting my classifier, which I mentioned. It's a pipeline, and said this will help me using extract text, examples, labels I have to give, and that's all, right? So see, train example. If I show you, uh, it's a text, right? So this text you will give, and along with labels you will give, and that will work. But that's all you need to train the model, right? So it's easier to do in practice. It's just a little bit difficult to understand because you need several things to understand before the word embedding. Maybe RNN, LSTM structures, then encoding decoder, then you will learn transformers. Inside this BERT or something like that will come, and then it will have worked, right? So, but you don't have to go through this. What you can do is you just write this code, not this, but any code, which will so any kind of data you can take, that I want this data, something like that. Like, so here I have data in the form of uh, array, right? So this is currently array. Like this was actually terrible movie something. You can have similar kind of data, and you can use a model using this way, right? So this whole thing you have to just copy paste it, change the link of it, like whatever given here, you have to change it, um, and we can actually go to this EF hub. Yeah.
So, sir, in this way, without using API, we can directly import the model, right?
Without using API, it's kind of, but not everything will work. So this is actually in the TensorFlow. That's why it's working. Otherwise, it wouldn't have worked. You
And
need.
sir, what about those Kaggle models? Will those work or not without API?
I don't think so. Everything will work. Some will work. Not sure about it. Like how.
Okay, sir, no problem.
So see, what we did is we imported TensorFlow as hub, and this TensorFlow is actually doing that part for us. Now you have to figure it out how you can do it. You can ask to ChatGPT how you can import and how it will work. Will you require API for this or not? But you will require API for few things. Right? I think DeepSeek and all will not work. You will require API for that.
Okay, sir.
Yeah. So that's all is there for this. Like you can basically use transfer learning to train the model. That is the idea. So this is what semi-supervised learning is. We don't do, so in supervised learning we train the whole model, but here we take a pre-trained model a little bit, and then on top of it we train it, and then do the supervised learning. So it's called semi-supervised, or you can say transfer learning. So this particular portion is a transfer learning in that also. Okay. Okay, yeah, that. Okay. Just one thing maybe you need to understand about this. What is this class? How can I write a class by yourself? So you can also write a class using scalar. So you just have to mention what is a model about, what is the function behind it, then how does the fitting works, right? So fit, then what will it will return, then transform what it will return. So generally transformers, wherever you do transformation, you don't do you don't return anything here, right? So could be um, like after fitting you don't return, you transform and then return something, right? So you have to experiment with this, probably a skill and base to understand this part, but I never so see, as of now I don't recommend do this. If you want to understand it, but later on what you will realize is you will use something very different in terms of programming to solve this kind of problem. You not go with similar structure, but to understand it, you can go ahead, right? So understanding something, because it will be similar only. With TensorFlow, you can do this way. With PyTorch, maybe you have to look up like what you can do with PyTorch, how you can train using PyTorch or something like that. So that's all I guess we have for today. This notebook is present here, and I think I should the same link give in chat also. I'll just paste it again if somebody joined you.
Sir, can you share the collab link?
Collab is here. You go to this page, practical employment transfer lane, same thing.
Okay.
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 Yeah.
And sir, that class have you created, or is it already part of the
It
model?
is no, it's not part of the model. It's been created manually. So this imported class sklearn.base, and then we are inheriting this base estimated transform mixin to create a new class, text feature extractor class. We are creating this, and which requires three things, right? So this is a initiation
Okay,
of
sir.
it,
Thank you.
and then two more things. Okay. So this methods and all you have to look up how to write if you are not aware of Python inheritance and all, something you have to look up, and then you can do it.
So in this collab, you write define in itself. There is two line which is hashable self model name. So that it is related to we write self model name in two method like this above.
You mean we write
There is two
different
green line.
to green line? This one?
No,
Here?
no, sir. Behind, below this, these two hashable.
This one?
Uh,
This is commented out. So I mean, so what's happening is same thing, but here you will get 128 dimension data. Here you will get 150 dimension data, something like this. So it's a depending on like output or something, right? So they have trained different models of this, and currently we are using this last one. If you wish to use, let's say, second one, you can comment out the other.
Okay.
So it depends, like maybe one was not working, so it is written like that.
Okay. So in Kaggle, we see some of the model are work on the TensorFlow, like
In Kaggle,
yes.
could be. So see, they are mentioning how to use it, right? So import transfer, then you can load it this way. So so it will be given how to do some model, but yes, it's not necessary that they use TensorFlow only. Depends on the people who are publishing it, right? So this is published by Google, and Google uses TensorFlow because it's their framework. Maybe somebody would have uploaded in PyTorch as well.
Yes.
But sure.
Most of the model I see PyTorch and TensorFlow.
Yeah, those two only exist frameworks which works with deep learning, right? So those two are deep learning frameworks. DBC, this Meta would have used, for example, it does not have license, but they would have used PyTorch. For this, maybe you'll require API keys. How to do. So now there's a model path. It's downloaded somewhere. Yeah. So this all now it's experimentation, how you can write it, and all. Even I am not um, thoroughly aware, like how do you exactly write it. It's kind of debugging. You can take up others notebook and you can try it out. Okay, yeah, thanks. So that's all for today's class. By the way, this is not in enter, so don't worry.
Yeah, 12th week is not coming in exam.
Yes,
Till 11.
just 1 to 11.
So from learning perspective, this is really important, right? This is, I mean, nowadays deep learning and then LLM and these are becoming kind of important to
No, actually, you will when you learn deep learning, you'll not use this. You'll not use sklearn basically after that, right? So you'll not create a model using. You'll not use sklearn classifier or something like that. You use deep learning models, right? So ANN, CNN for images, RNN for text data, encoder, decoder you will use, and such things. So this transfer
So
learning.
these will be discussed as part of deep learning course in detail.
So there is another course which is deep learning practice, where it will be discussed how to write the program about it. So deep learning course itself is, you learn deep learning first. What is that about? And there
Something
is,
similar to MLT and then MLP, right?
yes, correct.
Theory and then this. Okay, sir.
Okay, stop in streaming. Uh, yeah.